So it is a SQL Advanced Training demo. So Mr. Chukwumeka, today we did not have a demo for basic. We'll be having it tomorrow or day after tomorrow, rather Thursday. But because 7 to 8 I was occupied, Thursday we will continue with the demo. So now today it will be SQL Advanced and the demo from 9:30 to 10:30. Which is going to be SQL Server Basic for data engineers and data analysts. So at 8:30, we start the demo of SQL Advanced session.
Right. Okay. Thank you. So I can go out. I can log
Yeah,
out.
you can. Yeah, because we actually have continuous demos today. Also, we should have had, but there was something urgent that has come up today and tomorrow between 7-8. So we will continue with basic demo on Thursday.
Okay. Okay. So there's something I want to clarify.
Yes.
There is another email I got for new SQL Server for data analysts and data engineers.
Yes.
That's starting on the 16th by 9:30 a.m.
Yes, Indian time 9:30 a.m. So in here, so we'll be looking at table structures and index structures. Then locking and concurrency and transactions. So we'll be looking at transactions first. What is a transaction in SQL Server? How can I work with transaction? What are the modes that are there? Then we will be looking at how does SQL Server lock a resource when a resource is being utilized. Then we will look at if there are multiple transactions, how can we isolate one transaction from another transaction? We'll be looking at blocking, deadlock, latches, spin locks. So we will be dealing with this primarily, and it is elaborate dealing with these topics. Then finally, we'll go to query optimization. So we'll look at how the query is processed by SQL Server. How does it create an execution plan for the query internally? Then what are the factors that will decide the execution plan? What are the operators that get involved in an execution plan, right? So like statistics. So understanding the execution plan in terms of what are the operators, and if there are any problems with my query because of which my query is not performing well, how do I modify? Right. So this is what we will look at. And how do I look at a plan? If I create a query, how do I look at a plan to find out, okay, this is the plan for this query. And can I freeze the plan? Like, can I say that for this query, only this plan should be used? So these are the things that we will be looking at in query optimization. We'll also look at how index is affecting our optimization. So that is also a point that we would be looking at. So these are the topics that are covered as part of the advanced course. It's 45 hours and it'll be 1 hour per day and it'll be 5 days a week. So approximately this goes on for around 2 months. Of course, you can choose the timing, suggested timing. The actual timing that we start is between 8:30 and 9:30. But based on the participants who are going to be participating in the program, and also we will look at what is the convenient time, and based on that we will be having the timing fixed. So this is the topic that we are dealing with, topics that we are dealing with. We started with the first topic yesterday, which is called common table expression. And we said that what is this common table expression? Common table expression is a feature given by T-SQL, and it improves the readability and the ease in maintenance of complex queries and subqueries. So we will look at how this is being done. And common table expression cannot be used like you create common table expression once, and it cannot be used anywhere we want. It can be used only with the query which is following the common table expression immediately. And common table expressions advantage is there is no temporary table created in memory. And we'll also see there is an option for me to access data in a recursive manner. So these are some of the advantages of the feature called common table expression. Now let's move on to the common table expression need. So we were looking at it yesterday. So suppose I want to find out the territory with maximum number of orders. Then I have a territory here, which is territory number 10, and I have number of orders that it gives me. This is an example. This is what I want. So how do we start with writing the query? So if I have knowledge about query, we will start the writing in this manner. So first you will find out territory wise what is the count of orders. Just before we see this, let us see the database linked to this. So the database that I am linking to here is the AdventureWorks database, and it is very convenient because it already has data populated and it simulates the retail selling business. So this is my AdventureWorks, and we are working with a table called sales order header. So yesterday I did mention a brief about this table. So this AdventureWorks database contains information. It is information about sales, purchase, inventory. So it is basically a company which is manufacturing cycles, or you say bikes. Bikes means we are talking about cycle only. In India, it is called cycle. Outside, it is referred to as bike. So that is the manufacturing, and it also manufactures related items. So this is the scenario that we are going to see, and this example is taken, and therefore you can extend this example to other projects which have similar sales or retail sales scenario. So here we have sales order header. This table gives me the summary of the sales. And then I have something called sales order detail, which is there on top in here. And this table gives me the detail about the sales that is happening. We are going to pick. So in the summary, it is telling every cell that what is the information that it is giving. The information is for a given sales, what are the order date, due date, ship date, etc., the different dates, statuses. It is also giving what is the total amount, and it also gives where the sales happened. That means I'm selling to which territory, the person belongs to which territory, etc. So all this information is there. Customer ID is also there. You can see. So all this information is present in your sales header, sales order header. The sales order detail gives me information for every sales order. So for every sales order, you may have multiple products that you are having and which you are purchasing. And not all products may be shipped together. So there can be different carrier tracking numbers or different shipping numbers. Like suppose I ask for 10 products and 2 products is available right now in the warehouse. So they immediately ship. The other 8 products are not available. So they will ship as and when they make it available. So that is why you have, for every order, you can have the details listed here. So now what is the query? The query is, I want the territory with maximum number of orders. So again here to confirm, we are assuming people are very familiar with query, and then we are starting with common table expression. If you're completely new to SQL Server, there is another session, basic session, which starts between 7:30 and 8:30, whose demo is not there today and tomorrow, but it will be there day after tomorrow. So just wanted to confirm that. So this part. Okay, so I want the territory with maximum number of orders, and this information comes from the header. So for every order, I have a particular territory ID. and I just want to count the number of orders for a given territory. So first let's get the count. So we showed yesterday. So select territory ID, count sales order ID, and group by territory ID. So a simple query. So this gives me territory ID wise the number of sales. Suppose I order it in by number of orders. What is number of orders? It's an alias that I have given to count of sales order ID. So this gives me the number of order and it is descending. So you can see it is in descending order. Now from this, how can I get max? So the problem that we were facing yesterday was if I use max of count here, it will not allow me to do that because max is an aggregate function and count is also an aggregate function. Both being aggregate function, you cannot nest them. What do I mean by nest them? First count and then get the max. Both cannot be done. So you can see that it is giving an error to me. And the error is, it says cannot perform an aggregate function on an expression containing an aggregate. So here you can see this is the expression count sales order ID. It's an aggregate function and I cannot use max on top of it. So what do? I can do and I can have one way of doing it or one method of doing it. This whole count, which is giving me a count, territory wise count of orders, I can create this as a subquery and use this subquery in the from clause. And we said that we can do this and we can get the information. So I'm just repeating it for the sake of people who are completely new as in today, who have just come in today. So this is basically giving me territory wise number of orders. And I do a select star. So this is a subquery example that we are taking. Select star from and this whole subquery. And this instead of star, I put max now. So I say max. And in max, I say I want number of orders. So max number of orders. So select max number of orders. And I also want the territory, but territory, it won't make sense because you just are not going to get the data. So we say max number of orders and we also say here group by. So I give a group by clause here and I say group by territory ID. So or in fact, once I get the max, the group by is not required. And the order by which is there, that also I remove because it's a subquery in the from clause. So it's a derived table. This is what we have. So now when I get this information, it gives me the order, maximum number of order, which is, you can see here, 6,843. Now the question is, I want the territory and the number of orders. Now one may say, why can't I put it this way? So territory and order, it's not going to work because when I use territory ID, group by territory ID, then it will give me maximum inside every territory. But right now I want the territory with maximum number of orders. So if I just say group by here, it will get into a loop. So if I say group by territory ID, so it gets into a loop. So you can see whatever this is giving, the same that also gives. This is giving the count. So therefore this won't work. So what I do, I have this max. Now this similarly, I can also use minimum. Suppose I say in a given query, I want to get the minimum and the maximum. So what will you do? You will have maximum order and minimum order. So we have two queries. So we can see that you have minimum number of orders and maximum number of orders. So these are two separate queries that you have written. So 352 is the minimum number of orders and 6,843 is maximum number of orders. Now, how do I get both minimum, maximum with the territory? So we do this. We say select, you say territory ID and number of orders. And we say that select this from, and here I write a query which gives me number of orders. So I can say as number of orders, territory wise number of orders. So this is what we have. And this territory wise number of orders, here I can specify the information, select territory ID and group by. So this information I specify. So this gives me territory wise number of orders, right? And I use a where clause here and I say where the number of orders equal to the minimum number of orders. So now you can see the query is getting slightly complicated. So here, this is the first thing that we do. Or the orders, the number of orders should be equal to maximum number of orders. So you have this, both of this coming into picture. Now, once you do this, then you are getting the data that you want. What is the data? Territory ID wise number of orders. So you can get the territory with minimum number of orders, territory with maximum number of orders as well. And the advantage of this is I can have two territories with the same number of orders. It will still give me the data because I am not using top here. I'm using max only. So this is how it is created. But we have seen that you see that this select territory wise number of orders is getting repeated once. Then it is repeating the second time here. Then it is repeating the third time here. So therefore the repetition is there. And I want to reduce this repetition because the query looks quite complex. So what I do, I go to this solution of common table expression. So I see that these three queries are repetition. And this repeated query can be encapsulated into a common table expression, which is called CTE. And therefore you have this information here. Now by this, what happens? You're creating a CTE. So this is how you create a common table expression. You say with the name of the common table expression and you specify what are those columns that the common table expression will give. So the columns that the common table expression will give me is the territory ID and the number of orders. So we have this. So you say with common table expression, territory wise number of orders. You say how many orders are there, and you reuse it in the two places. Which are the two places? In your where clause. So you can see here, select territory ID wise number of orders. Instead of specifying the query, you are replaced it with the common table expression. And the same thing that you have done here, you replaced it with the common table expression. You replaced it with the common table expression. The advantage is within this query, this is the outer query. Within this outer query, I can refer to the common table expressions any number of times. The first time I refer to, the common table expression is executed. From then on, I use the output of the common table expression. Because what is a common table expression? It is nothing but a select statement. And the output of the select statement is given it is actually executed once to get the output and enters given, multiple times it is reused. Now the question would be, can we do this without common table expression? Yes, we can. We could have done it even with a subquery, which is what we have done here, right? So we used a subquery. This is the subquery we used. And SQL Server automatically takes care of something called spooling. Spooling in the sense, if it comes to know the same query is being used multiple times as subquery, the output of that subquery will be saved in the memory. And therefore, the next time I refer to the query, it will refer directly to the output. It will not execute the query. That is the advantage. But then why do you have a CTE? Because the CTE is making it easy for me to read the data. So you can see here, I have the data CTE, right? Common table expression. And this is being used multiple times in my query. So it becomes pretty easy for me to write a query using a common table expression. You can make it a little more complex also, or rather you can make it even more easier. How do you make it easier? Simple, like how you have common table expression, which gives you territory wise number of orders. We can have common table expression, which is using another common table expression. So I can say, I will have max orders. Okay, this is my common table expression, which is giving me max orders. So I will say, what are the orders? Number of orders. So this max orders is returning number of orders. You can say maximum number of orders. Okay. And I can then say, this is my definition of the CT. What is the definition? I can make it more simpler. I can simply say, select maximum number of orders from common table expression. So here I have this whole thing encapsulated in a CTE. It's becoming more and more easy to read. So this is my second CTE. Then you can have another common table expression. These are called nested. Why it is called nested? Because this is a common table expression which you have defined here. And this is a common table expression, max number of orders, which you're defining based on what you defined earlier. So you can see these are nested common table expressions. So we have maximum number of order. We can also have minimum number of orders. Right, and we can change this instead of max to min. Okay, and then what I do is, these are the two, you can say, two nested common table expressions or two common table expressions based on another common table expression. So instead of using this whole query here, I simply change it to this equal to select star from max number of orders. So when you say select star from max orders, so you don't, it becomes pretty easy. Select star from max orders. And then you say select star from min orders. So you are saying select star from minimum number of orders. These are the two common table expressions. So you see, this is my main query. So I'm going to comment on this. This is my main query. And then these are your common table expressions. So what are the common table expressions? First is common table expression. CTE is the abbreviation for common table expression. So common table expression giving territory wise orders. Okay, and then next you have common table expression, which is giving me maximum orders. And then you have the common table expression, which is giving me minimum orders. So instead of maximum orders, you say maximum number of orders. So here we have minimum number of orders. And this is my main query. So when I execute, if I have not made any syntax error, it should actually do the same that that we have been doing. So this is going to give me the same output. So let's go through the output, execute the query and check the output. So it is giving me an error. Let me just check. So we have this with as okay. So I don't require width here. The moment I have multiple common table expressions, width is not required. Only the first common table expression I write width. So this is the error, and let's now go through the query. And get the data. Now, what is the difference between this and the previous one? The previous one, it was quite complex. You can see it's quite complex. It looks complex, though it is simple, and it is very difficult to debug. Whereas here it becomes pretty easy to debug because you have moduled it. And second, as we said, the first time this common table expression is accessed, it is going to execute the query. From then on, the output of this query is going to be used. Right? That is the advantage of the common table expression that we can see. And the main query, it becomes very simplified. So we can execute actually and see, okay, this part is getting executed fine. Okay, so when you are executing, of course, you have to execute with the common table expression. So you know the scope is the current query. So it's giving me this territory wise number of orders. Then I do it with max number of orders. So it will give me a territory with maximum number of orders. And then I will include this second or the where clause, second condition after or. It gives me both max and minimum. So like this, we are going to see some more examples where common table expressions are used. Right? So this is the purpose of the common table expression. Let's take another example where we use the common table expression. What if I want this output? What is the output? I want the year of sales. Then I want the previous year sales. You can say if you want number of orders, but that makes it a little more complex. Let's make it as previous year sales. Okay. What is the total or consolidated previous year sales? And I want consolidated current year CY. Previous year is PY, you can write. Current year is CY, current year sales. And I want to find out the trend. So when I say sales, I'm talking about the total sales amount. So I would have sold so many for so much of rupees. I would have sold for so many dollars. That, and the trend will tell me whether my revenue which I am getting is positive or negative. Year by year. So year on year we want to see. So for example, if I say 2011, suppose that is the year when the sales started, then the previous year sales will be null. Then the current year sales, let us assume, is say 2 lakh, some amount. Then in 2012, the previous year sales will be what is current year sales here. So this is your previous year sales. right? So this one we have, and then for 2013 we are having here. So let us assume that the current year sales for 2012 is 2000 or 3000, 3 lakh. Okay, I think it is 3 lakh, or I think it's 30 lakh. And now here again the previous year is going to be 30 lakh, and here whatever it is. So it can be 20 lakh again. So you can see this, and then you have the trend. What is the trend? The trend is simple. You subtract the current year and the previous year. So the trend is your sale is up by 20 lakh. So this is my upward trend. And then you have the sale here, which is increased by 10 lakh. So this is an upward trend. And then here it is a downward trend because the sale has reduced by 10 lakh. This is the output I want. And we are going to see how to use common table expression for getting the same output. So first, let's work step by step. First, I want year-wise sales. And for getting year-wise sales, we are going to use two important columns from the sales order header table. And the two important columns for sales order header table is the order date and the subtotal. Subtotal here means whatever sales has been done, what is the total amount. And we want year-wise sales. So for getting the year, we are going to use the order date. So we say select, and we are going to use the function year of order date as sales year. So we can see this is my sales year. And then we are going to sum or total the subtotal or total due. So total due means how much amount is due from the customer as the sales amount. So that will tell me what is the revenue. Here we are not looking at what is the revenue expected or what is the revenue which has to come back. We are not looking at that. We are just looking at the revenue. So here you have year. So this is my total sales amount, and we say from sales dot sales order header. This is my table, and I say group by year of order date. In group by clause, remember we cannot, as we are doing this, the prior knowledge one should have is in group by clause, I cannot use an alias because aliasing a column, which is called column alias, is done after the grouping and summary. So here you cannot use the column alias because the group by clause will not recognize the column alias. Whereas order by, it is quite different. So just because this point of aliasing has come and we are aliasing here, giving different names to the calculated column, I made this point that aliasing will not be available when you're grouping, but it will be available when you're ordering. So in an order by clause, I can use an alias, but not in a group by clause. So that is the point. So let us look at this. So it is giving me year-wise now sales amount, and the starting year you can do an order by here. So order by, we can do order by sales here. Remember, order by, I can use the alias. So it will order by 2011, this was the sales. So what is the first year of sales? The first year of sales is 2011. That means 2010 we had no sales. So this is my first query that I would be using. Now before we proceed further, just a small interruption. As we are doing all of this, I just wanted to ensure that you have the URL where you would be filling the student information form. So in case you have not filled the form yesterday and you are interested in continuing with the session after the demo sessions are over, you have to give your information, and you would actually be getting a mail or a response from Go Online Training. So let me just copy this URL to the chat window and make it available for everybody who is present here. Just give me a minute. Okay. So I have a general chat. So it is visible to everybody. So this is the URL that I'm sending. So those who want to continue after today or after the demo sessions, I think 2 or 3 demo sessions, so we may have. So those who want to continue, please type in, send or click on this URL, fill the information form and give it to Go Online. They will contact you and you can then further have the communication and decide whether to attend and continue attending the training. This part I wanted to ensure. So it is there in the window, chat window, and I am going to share now my screen. So I will also use a notepad to show this URL. So this is the notepad. So you can see the screen now, and you can see that the notepad is there in the screens. Okay, this is the URL that one can click. So at the end of this training, today's session, you can try, you fill this form and then you can have the session. So after the demo sessions are over, 2 or 3 demo sessions we are planning. So based on this is the second demo session for advanced SQL. So after this, mostly it will be a regular session. We are planning to continue attending this session. Please fill in this form and they will get back to you. So let us continue with what we were doing. So we wanted year-wise total number of sales first. So I got this total number of sales year-wise. You can also say, I want the number of orders. So you can also say count number of orders, and you can say order by. So, but it becomes a little more because we want, instead of sum of orders, we want to count the orders. You can do that as well. But here I'm using the total amount. Total revenue, you can also say. Sales year and the revenue. I would like to change the alias to revenue. So it will give you year-wise revenue. Now, how do I get this? What is it that I want? So here we use the technique of self-join. So we'll first do it using subquery and then we will convert it into a common table expression. So this is going to give me year-wise revenue. Now I want the same year-wise revenue to be used twice. And we have seen in the basics, it is supposed to be known, there is something called self-join. So you can join the same table, but in 2 different roles. We are going to play something similar to that. So we are going to have this year-wise sales or year-wise revenue, and the same output, we are going to use it as previous year and current year. So I will give this as current year revenue, CY revenue, and the same select statement I'm going to use in my from clause. So from current year revenue, and then you're going to do a join. But before we do the join, let us look at the second way we use the same query. So you can see the query is the same. it's giving me year-wise revenue. And instead of current year revenue, I say this is my previous year revenue. Okay. And this detail I would get. So this is my sales year. This is my sales year. Now I'm going to do a join. So now if you notice, this is my from clause. This is my outer query. These are two inner queries. And the inner query is the same. So I'm going to now use a join operator. And I say, I want to include the previous year revenue as well, even if the revenue is not there. So of course, I want the current year revenue and the previous year revenue, even if previous year revenue is not there. One option is to do right outer join. I'm now assuming again, people know what is right outer join because it will be covered as basics. So right outer join. And I am going to be using the join condition. So right outer join on what? On the year which is there for the current year, which is sales year for current year revenue. So I will say on current year revenue dot sales year has to be equal to previous year revenue dot sales year plus 1. And because it's an outer join, what does the outer join do? When this condition is met, it will join. And even when the condition is not met, it will give me the output from the second table. The second table here is the previous year revenue. So this is what we are looking at in the join condition. So we say from clause, and in my select clause, I want what all. So you look at the output I want. I want the year of sales, which is the current year of sales. So which means I will select here and say CY dot revenue or current year revenue dot I want the sales year. So current year revenue sales year will be current year, comma, the previous year revenue dot sales year. So you can have both, and you are going to say as current year and you say as previous year. So we give the two aliases, and then we say current year revenue dot revenue, and we want previous year revenue dot revenue. And you will say here, this is current year revenue. And this is my previous year revenue. So this is what we get. And once we join, it's a right outer join. Okay, so I have to remove the order by clauses. So I remove the order by clauses in my subquery. And then I execute. So you can see here, I have now partially achieved what I wanted to achieve. So I got this details. So, and now I order by. So in the outer query, I have to order by. So I say order by current year revenue dot the sales year. So this will order by the current year. Now the previous year is 2014. And for 2014, you will have no current year because in 2014, so for current year 2011, so I think I will change slightly because it is giving a wrong information. Let us see here. 2011 is the previous year. I think I have, yes, 2011 is my previous year. So my current year is 2012. So current year revenue is this much, this much. Okay. So from in here, it is giving me the right data. but here it is giving me the wrong data. So in 2014, there is no. So let me do a left outer join instead of right outer join, because I want the previous year and the current year change. So let's see here. Yes, now you have it in the right order. So I do the left outer join, and current year revenue is there, previous year revenue is there. So current year 2011 revenue is this much. And in 2010, there is no revenue. It is null because 2010 is also null. There is no data at all available for 2010 because the first point when you started the business was 2011. Then 2012, you do have this current year revenue of 2011 coming as previous year revenue. You can see. And then 2012, you have the current year revenue. And in 2013, that becomes the previous year revenue. So you can see this. You can see these two are the same. And then, of course, in 2014, 2013 is the previous year. You can see here. And the 2013, which is the previous year, that will be the previous year sales. So you can see the sales are matching. And this is my current year sales for 2013. This is how it goes. So this we have got. And if you want a trend, the trend is very easy. All that you have to do is subtract. So we do a subtraction here. And we say that subtraction is the trend. So what is the subtraction that we do? The current year revenue minus the previous year revenue. And this is the trend. Okay, so sorry, previous year revenue dot revenue, and this is my current year revenue dot revenue. Instead of current year revenue. Oh, okay. I think I did a mistake somewhere. Okay. So this is my current year revenue. See, right? Okay. Dot revenue as current year revenue. Okay, this is how it is, and this is my previous year revenue. So we can have this, and then we subtract here. So we can see here current year revenue dot revenue. We subtract it with previous year revenue dot revenue, and that gives me the trend. So this is a calculated column. So now you get the total data and you get the trend. Of course, when the trend is there, you want to show the hand or no. So you can see there is a negative trend in 2014, 2013. In 2013, you had more sales, and in 2014, it has reduced. So 48 minus 22, you're getting 26. So there is a negative trend. And when you go to reporting, you can always say when the data is negative, then the trend is down, and the data is positive, the trend is up. So you can have this information. This will give us, this is what we wanted. Now, how do we convert this into common table expression? That point we will see in the next class, which is tomorrow. If there's any question, any one of you, Hanumant, Ramesh, Shaul, and then I have XX. So I do not know the name. So if you can tell the name, it would be fine. So we'll stop the session today and we will continue tomorrow. If there's anything, any query, just let me know. If there's no query, please ensure that you fill the form that I have just mentioned It is there on the screen right now. This is the URL and it is there in your chat window as well. So please go through the chat window and you can fill in the form.
Sir,
Yes.
I'm Hanuman, sir.
Yes, Hanumant.
Yesterday, actually, I got the invite, sir, but I couldn't attend the class yesterday because of some mishap, like, which I could not attend. Do I have that access to that yesterday's recording, sir? I'll fill
Yesterday's
out this
recording
form
you will
today.
have access. Same advanced you're talking about. Yes, you have the access.
Yes, sir, about the advanced one. Yes, sir.
Yes, you can have, you have the access.
Yes, sir. I'll go through that and fill out the form today, sir.
Sure, sure. Thank you, Hanuman.
Yeah, thank you, sir.
Any other questions from Shahul or so?
No, sir. For me, no questions. I will fill up.
Yes, and the XX, I do not know the name. Here, Ramesh is left, so XX. Okay. If there is no further query, you can fill in the form. The next session is starting for me, which is on SQL Server for people who are working in IT and who are wanting to be data analyst or data engineer. There's a modification in the course coverage. So that is the next course we'll be starting. So the demo will go on. So those who have completed can log out.